I just wanted you to remind. I just wanted to remind you that there's no food allowed within the amphitheater, including coffee. And I'm the first culprit. I just brought coffee in there. I just had to put it away. So please don't bring coffee in there. And I try to make the talk entertaining so that it will wake you up without a need for coffee. That's my challenge today. We're going to talk about App Engine Java, so that should help. All right. So maybe let's get started. So hello everybody, my name is Patrick Chenezon. I'm a developer advocate with Google since 2005. And at Google I've been doing many different types of APIs. Typically I switch every year or two. So I've done AdWords and then Checkout and then Open Social, then HTML5, and this year my focus has been on cloud computing. And you'll see I'm going to tell you about all the Google developer product offerings in the area of cloud computing today. So I'm French and I'm based in San Francisco, and this is actually my fourth time, I think, in Singapore. So I'm very glad to be back today. Okay, so there's lots of ground to cover in this presentation. Basically what I'm doing here is that I'm kind of summarizing in 1 hour. Let's try to make time. In 1 hour, what we presented at Google I/O in May, with lots of new product announcements. And basically, this is the content of maybe like 4 1-hour presentations. So I'm going to go really quickly on the slides. The slides are available on my SlideShare account. So if you look in my Twitter, you'll find them. So there are more here for reference. I won't go in the details of every of the technologies. But I try to show you what's possible with all these technologies and where it could be of interest to you. Before I get started, I'd like to have a better idea about who you are and what you are interested in. So first, I'd like to know, do any of you today use Google Apps within their company or university or entity? Okay, right. Wow, quite a few. Lots of you have gone Google. That's great. Another question is, how many of you are like developers as a job, like you're coding every day? Wow, that's good. That's good. Any Java developers here today? Good, very, very good. Python? Oh wow, that's a good mix. We have a good crowd today. That's a very good mix. And then another thing, who among you have used any cloud computing services like Amazon EC2 or S3 or Rackspace or App Engine? Great. Any App Engine developers here? Wow, fantastic. That's like much higher than average. So let's go through it. So I'll start with what does cloud computing means. Essentially, it's like a current buzzword. So if some of you are playing buzzword bingo today, that's the first one to just buzz. It's been a buzzword for like a few years now, but basically what's behind it is two aspects. One of them is economic. So cloud computing allows you to just leverage the resources of companies that provide them to you. And typically you're not paying for, instead of paying for capital where you're buying your servers, host them in the data center and all that, you're just paying for what you're using with them. And the second aspect is technical and economical. The technical aspect is linked to the fact that these providers typically enjoy economies of scale when they can, for example, at Google, we're building our own servers, we have our own data centers. The fact that we are hosting all these applications for Google just gives us a lot of leverage in making the cost of computing just go down. And so basically, when we run that to you, you benefit from these economies of scale. And there's another aspect, which is elasticity. If you're building a mobile app that's super successful or a social app that's successful overnight, because we have lots of these applications running and lots of capacity, we're able to give you the elasticity and just to let you survive all the spikes that your application is going to have. So there's a technical and an economic angle to cloud computing. So what do we do at Google in the area of cloud computing, and what can you leverage? So basically, we let you build and buy apps in the cloud. Our first offering in the area was Google Apps, and it seems that many of you are using that today. So Google Apps is centered around collaboration, and we have a Premier Edition that companies are just buying for their domain, and then they can use Gmail and Docs and Calendar internally to collaborate. Now, all of you, I'm sure, are using within your company like more different kind of tools for CRM or accountancy, things like that. So there's lots of vertical type of applications that companies need and that are not provided by Google Apps, because in apps we just focus on collaboration and communication. So because of that, we introduced the Google Apps Marketplace that lets third-party developers develop apps and resell them or sell them to Google Apps Premier customers. And I'll show you how that stuff works. For those of you who are developers, this is a great opportunity for monetization. And actually, there's one company in Singapore who's kind of our poster child for Google Apps Marketplace. They're called Social Walk, and they're kind of a Twitter for the enterprise. And they've done really well in the apps marketplace. I'll show you how that works. And then the other, but even with all these apps in the marketplace, there are lots of needs that may be very specific to your company or that are not met today by some apps in the marketplace. So you still need to build some apps that are really custom to your company's needs. And in order to build them, we have another offering that's called Google App Engine for Business that was introduced at Google I/O, and I'll tell you a little bit how that works. And basically, App Engine for Business allows you to build your apps on top of our infrastructure and just have them be accessible by the users from your domain. Okay, so customers want more apps. The apps marketplace, so I told you about that. So we're just doing messaging and collaboration. So when you're a developer and you want to create an app that runs on the apps marketplace, the first steps are very easy. So basically, you use any tools you want to build your apps. It just needs to be a web app. And then you need to integrate it with Google Apps. And the way you do that is the required aspect of it is OpenID for a single sign-on. So that when the domain user is logged into their Gmail account, when they switch to your app, you recognize them as a user. But that's only scratching the surface. That's kind of the required aspect of it. Now, where it becomes much more interesting is that there are some aspects of your apps where you may want to leverage some of the services that are provided in Google Apps, like Docs or Calendar, or lots of integration. And most of the surface area of all these products in Google Apps is available through APIs. And so when you're building your apps marketplace application, you have the ability quite easily to integrate with all these services. And that's other of the reasons why we love Social Walk, because they're kind of one of the most comprehensive. They integrated with nearly every of the products down there. And in order to integrate, we use two technologies. One of them is called OAuth. If you followed Timothy and Bob's presentation before, this is the same standards that we're using in Buzz and in Open Social as well. So it's a standard for authorization. And then we're using Google data, which is basically a thin layer on top of the Atom Publishing API that actually Bob and Tim told you about. So you can see some themes here, which is we're trying to leverage open standards as much as we can in most of the products we're doing. And then once you have published your app to the marketplace, you can start sell it. And there are 2 million businesses and 25 million users in there that can buy it. And once companies start buying it, this is where you'll understand why we're doing this, because we take a 20% revenue share from you. So there's lots of type of apps in the cloud. I told you about integration points. So how it's done. Instead of showing you these kind of graphics, I think I'll just go straight to the point and I'll show you how it works. So I'll do it with this mic. So let me switch to my Google account. And okay, so I have lots of stuff open. I'm sorry, I was coding when they were talking before, so I opened a bunch of tabs. Trying to make some of the demos that I'm going to show you work. Okay, so this is what I wanted to show you. Yeah, so this is actually my personal email. So I have my domain, my family domain called chienezon.com, where this is kind of my private company with my wife and my kids. They all have email addresses in there, and I'm kind of using it as a test bed to show you what you can do in your private domain if you were a company. And you had both Google Apps. So I'm running Google Apps on there, so I have access to mail, and calendar, and document, and sites, and more stuff. Now, Patrick at chienezon.com, I'm the administrator of that domain. And in that domain, I need a new type of application. And I'm actually going to install one that I haven't installed yet, so I don't know yet what I need, but I need something. So I'm just going to go to the apps marketplace. All right, so I go to the apps marketplace, and here I see, wow, there are lots of categories. So you can have accounting apps and stuff like that. There are some feature apps like Zoho. Slide Rocket. Okay, I'm doing lots of presentation. Maybe I'm going to install this one. So let's see what this is about. So I just click on there. I'm going to go to the product listing view. And so when you're building your app, you just can fill all that out. Let me see if I need to pay these guys. What's the price? Oh, it's free. Wow, that's great. I'll add it to my domain. Then how can you beat a free app? So I'm going to add it now. And which domain is it? It's chienezon.com. Yeah. And the next step, it's going to ask me to log in. So I'm going to log in with my super secret password. All right. So I'm the administrator for that domain, so it knows it. And then I go through that workflow that's kind of standard, and that's driven by an XML file that I'll show you afterwards, where you, the application developer, you just decide which services you need to have access to for the user. So here, first I need to agree to the terms of service of that application, so yes, I agree. And then it's going to ask me to grant them access to a bunch of services that are part of Google Apps. So they want to be able to add and remove users to my Slide Rocket account, so sure, that's reasonable. They want to be able to read and write my tables and charts and spreadsheets so that I can integrate them into my presentation. So I'm going to say yes, read and write on spreadsheets, and then they want to have access to all the contacts of my users. So I'm going to grant data access to this application for all my users. So when I do that, actually, they're going to receive an OAuth token for my users so they can make requests to get all access to their data. External configuration. Oh, there's some additional configuration. Okay, so I didn't know that app. I just wanted to show you like an app that I haven't tried yet. So let's go to see if there's some. So if you have additional configuration that you need in there, you are redirected to the app itself. And I'm going to go to the additional configuration in there. Okay, so I'm limited to one user, and I'm going to use my... So what you saw here, you saw this interaction where... So I'm redirected to their advanced configuration option, but just in the step before, I gave them access to all the address book of my domain. So what they did in this little transition is that they used the Google Data API using the OAuth token that I gave them to just pull the address book for my domain. And here they can present me all the users, so you can see my wife and my kids and all that. They have access to all that stuff. So I'm going to, and they decided in their business model that they give it to me for free for one user. Maybe if I want more, I need to pay them for something. So since I'm just going to show it to you for one user, that's fine. Okay, where do I... All right, that's it. Where do I go next? Maybe... Yeah, so that's me. I just want this guy. Okay, let's see if it works. So I did the additional configuration, and then I just want to enable it. Okay, where do I go next? In there?
On this page. That page, press back.
Oh, there? Oh, right. Oh, you're right. I'm kind of stuck. So, this is... Oh, did you see a continue button? Oh. Wow. So, oh, you're right, decreasing the font size. So I have enabled one user and then I don't know where to go. So I would say that's a pretty bad example. So maybe I contact these guys after this talk and I tell them, oh, there's something wrong with your process. But basically after that, I can enable the app for all my users. And now what I'm going to show you is what this looks like for apps that were, let's say, a little easier to set up, like a social work or some others. So I'm just going to go to my email or calendar account again. So where was I? Yeah, so that's my calendar. So here I'm Patrick Chenezon. I'm a user of that domain. And here you see I have documents and sites, and here I have more. And in the more here, you see a bunch of apps that I have installed in previous demos that I did like that. So for example, I have Social Work. So all the users in my domain have access to Social Work, which is this application made in Singapore. So I'm going to allow them access to everything, and you see they're pretty impressive. They integrated with Gmail, Calendar, Docs, Contacts. They use lots of that stuff. And so here I'm redirected to the Social Work application where now they have access to all my documents, and I can. And Social Work is kind of like Twitter for your own company. So here you can tweet and share status. So great, Preso in Singapore. And I can attach some stuff. So here I can attach some documents, and it's just going to pull all the documents using the document list API. So I could restrict it to just the presentation. So maybe I gave some prezos before. So that's a presentation done by my daughter. So I'm going to add that. I'm going to attach that to the status update. And maybe I can attach a calendar event, or yeah, actually I'm going to do a quick add event. And then I'm going to share that. And so all the people in my domain are going to see that, and then they can and then there's automatically a meeting that's added to my calendar, so I can view the details. When I ask to view the details, I'm just redirected to calendar. It's all single sign-on. So you can see that I have this new appointment in my calendar for today. So that's kind of, in summary, what Google Apps Marketplace allows you to do. Now, getting a little bit behind the scene, how do you code for that? So the first thing you need to do is to implement single sign-on using OpenID. So OpenID is a standard for single sign-on, and there are libraries in most of languages that implement it, and this is an example of code in PHP, just to implement that on your server side. I won't go in the details of that, but it's a pretty simple handshake. Now, how do you specify all these, like your OpenID endpoint and what your app is about and stuff like that? You specify that into this manifest file, this XML file, where you specify your OpenID endpoint, the kind of services you need to have the user, the admin grant you access to. So here, this is an example where for the setup link, you saw in the other application that was a little bit complicated, they had this additional configuration link, so they provided there as well. And then they provide the OpenID realm here. Now, the second step, you remember, some of the apps ask me for access to some of my services in there. And so user provisioning or docs or contacts. So the way you do that is that in the application manifest, all these services are exposed as Google Data APIs, which mean Atom feeds. So you just specify the URL of the feed that you want to have access to, and then the reason why you want to have access to that. So for example, if you're asking me to read and write all my documents, I'd like to know before why you want to write them, for example. Maybe I want to save some stuff from your app in there. So you specify some reasons in there. And then in order to access the data, you're using OAuth for delegating authentication. So typically the way it works is that your application is getting access to a token. You store that in your database associated to the user, and then you can use that token to access their private feed, Atom feed for that. So that's some PHP code to do that. And basically that's it for integration. That's what you need to do. So the initial integration, just with OpenID, if you have, basically you use an OpenID open source library to do the integration, and then if you have the notion of domains in your app already, you can do the integration in a day. It's very quick to do. After that, if you want to do deeper integration of other Google services like Docs and Contacts, it can take more time. But it's very easy to just get started quickly with that. Now, in addition to that apps integration, Google Apps started to offer other integration points that are really interesting. So what I showed you before was going from Google Apps to another app that leverages your data in there. Now, what I'm going to show you there with gadgets, it's different. It's your application which is going to be embedded within Google Apps. So, for example, you can have a gadget that represents your application that's embedded in Gmail or in Calendar. And before I go there, maybe I'll show you what it looks like. So there are many types of gadgets. There are Gmail sidebar gadgets, Calendar sidebar, sites and spreadsheets have gadgets as well. And what was introduced recently, I think it was around Google I/O, was two types of gadgets, Gmail contextual gadgets and Wave gadgets. And they allow some really deeper integration. What Gmail contextual gadgets are is that when people are reading their mail, you can specify a regular expression on the headers of the mail or the content that will trigger the apparition of your app if the mail matches that expression. So this is an example where in the regex for that application, they try to detect that this mail is about a specific task. And if they detect that, maybe they are looking for task or something like that, or want, or would like us, or so then they just add this gadget here, and the gadget just follows the same. It's the same specification as for OpenSocial and Wave gadgets, but it has access to additional APIs. And so here in this gadget, now you can have a complete application where within their mail client, they're interacting with your app. So Calendar also has gadgets where the gadget can be triggered when you're looking at a specific event. So this is what that looks like. The TripIt gadget, it looks at your calendar and then it tells you, oh, there are some TripIt entries associated to that. And let me show you what it looks like actually, because I have that installed, I think, in my personal account. If I can find it back. Maybe this guy will show it to me. Yeah. Alright. Yeah, so that's my Gmail account. And gadgets in Gmail have been around for a while as labs features, and you can see it in there. So this is, for example, the open source development application that allows you to develop JavaScript code, and this is just embedded in Gmail. And this is another sample application. And here you see it's a sidebar gadget, but when I open it, basically it's going to take all the real estate in Gmail, so it's a full app, it's a gadget. And in there, I can type in some JavaScript code and execute it to test the OpenSocial API. So you can see the results coming in there. And what it shows here is that the app through OpenSocial has access to the list of people in my address book. Yeah, so that's what these gadgets look like. And then sell. So in the manifest, most of the stuff that you see on the page when you're looking at the details of the page, you can specify that in the manifest. How do you set up your domain, the policy, support, and configuration. So you see that config link here for managing. I think that's the additional configuration link that I followed. And then, yeah, that's it. So you fill it, that manifest, you upload it to Marketplace, and then basically you can you submit it for approval, and when it's approved, you can start selling it to customers. The story here is that Google Apps Marketplace was introduced just a few months ago. I think it was in March. And for the companies who started building these apps, basically they saw a huge spike in the number of users they got. So there are some pretty good success stories here, and Social Walk is a good one from here in Singapore. Yeah, so there's a bunch of stuff that the team is working on in terms of roadmap, and you can learn more there. So that's Google Apps and Google Apps Marketplace. Now, if you're a developer and you want to build your application, we have another technology that's been around for a while, which is called Google App Engine. So I go very quickly on Google App Engine. It's I think I presented it here last year already, and I know a few of you are using it already. But basically, App Engine is our platform as a service offering. Basically, we take it's one level down from Google Apps. We have lots of servers and storage and all that, and we just expose that as a single platform with standard API in Python and Java. And if you write your application in these languages using these APIs, you just need to push your code to Google and we'll scale it for you. So the value proposition for App Engine is that it's easy to build, maintain, and scale apps. There's a bunch of stuff in there. Basically, there's hardware, networking, operating system, the runtime in Java and Python. So it's limited to Java or Python. If you're a PHP developer, you're out of luck with App Engine. We don't support PHP today. There's a port of PHP on top of the Java VM that's called Quarkus, but I don't know how good and how well it performs on App Engine. You can search static files in App Engine, and just at lunch I had a very interesting conversation with a developer who was using it just for that. So basically he packages his website instead of putting them on a single Apache host somewhere. He just creates an App Engine application that just has static files, pushes it out, and then we just serve it for them. In addition to that, there's a bunch of services that we have internally at Google that we expose through standard APIs. So Memcache is one, data store. Our data store is called Bigtable, and it is the main differentiator between a regular Java or Python app and an App Engine app. Bigtable is a distributed data store. It's not a SQL data store. So when you port an existing application to App Engine, typically you have to denormalize your model because you cannot do joins in a NoSQL database. There are URL fetching services. There are mail services. Tim and Bob showed you TweetDeck. One day I was looking at the internal dashboard that we have for like the top 100 apps on App Engine in terms of resource consumption. And who do I notice in there? TweetDeck. And I'm using TweetDeck and Sysmic, so I knew these guys. And I was thinking, why are they using App Engine for? What are they using it for? So I contact these guys, and I did an interview with them. And basically what they told me that they use App Engine mainly for sending email to their users. And they're making a heavy use of that. So there are many companies that start to do that because the price of sending email with App Engine is very low. XMPP service. Task queue is, so XMPP is to interact with chat. Task queues are very important to just break your application into smaller pieces, and especially to do asynchronous computation. So instead of having one request that takes an hour to perform, which is impossible in App Engine, you're limited to 30 seconds per request. We're asking you to break your request into smaller task units who can be chained together. So that there are like many different 30-second tasks that can run distributed in a cluster. Image processing API allows you to do image manipulation. Blob Store allows you to store large files. And there's a user service that lets you, instead of having to build these login screens, it's like automatically handled by the platform. Now, the good news about App Engine is that it's free to get started. So many developers don't pay Google anything. You have approximately 5 million page views per month with App Engine. So if your site is moderately successful, you should be under the threshold and you don't need to pay anything. It's free. Now, if you're going over that quota, basically you're paying for what you're using in terms of the CPU, bandwidth, and memory. So that's the model with App Engine. Because we're expecting that when you reach a certain level, you can monetize your application and then you can pay for usage. Lots of developers have used it. It's especially used a lot in social and mobile apps because typically they have this kind of social work is one of our poster children for App Engine. Oops. Yes. Oh, my computer is stuck. Yeah, so typically it's very used by social and mobile apps because they have this very spiky type of demands where if your social app starts to be really successful, in a few weeks you get millions of users. And if you had to manage the servers yourself, it's really a pain because it's very difficult to provision them in such a short time. Oh, I don't know why it's stuck like that. Mobile apps have the same kind of characteristics. Oh, maybe I'm running too much stuff. Yeah, that's it. Yeah, I'm starting to get low on memory. Maybe I should kill Seismic Desktop. All right. You guys are sending too many messages. So let's remove the apps that are eating all my. Okay. Wow. Okay. Yeah. So I told you that's social networking. I told you about that. Okay. Oh wow, there's something going on. It's really, really slow. Chilingo, yeah, Giga Socialize is a social app as well. And here you can see the kind of spiky traffic I was telling you about. You see these two, so basically they're socializing events, and they never know when they publicize an event whether it will be successful or not. But when it's successful, they get spikes like that, and this is the kind of elasticity that you get in cloud platforms. Okay, so that's App Engine Classic. It has existed for 2 years. First the Python version and then the Java version. Now, what we announced at Google I/O in May, which is like just 2 months ago, is a new offering targeted towards enterprise users, companies. So who among you are working in the enterprise? Like in large companies, maybe IT departments. Okay, just a few. So App Engine for Business is targeted towards companies. Basically, in the past few years, every time I went to discuss with large companies or consulting firms, I told them, hey, we have this great cloud computing platform, and it should be great for building intranet type of apps. They were laughing at me after 5 minutes saying, do you have support? Do you have SLA? Okay, well, call us when you have all that stuff. So that's what we did this year with App Engine for Business. Basically, it's the same platform with a few added features that enterprises have specifically asked us to develop, plus SLA and paid support. So, as part of the few features that we added, there's a centralized admin console. To give you an example of why this is useful, I think it was 2 years ago, I developed an app for Time.com. They were one of our partners at Google I/O, and I did an integration of Friend Connect in Time.com website. So I built that on top of App Engine, and we just had a development instance of it on App Engine, and then they pushed it to production, and they gave me admin rights on that application. Now we are 2 years later, and basically I still have admin rights on this Time.com application, and that shouldn't happen. So this is exactly why we built the centralized admin console, because here you can say, these are the developers who have the right to deploy some apps in my domain, and they need to have a domain account, and I can specify that users need to log in with their domain account to do that and all that. So there's a lot of security in there that you need if you start to have hundreds of these apps developed by many different partners. SLA and premium support, it's only for users in your domain. The pricing is different. So here you pay by user, by active user per month. And the enterprise features, basically we're adding SQL support. So it's not ready yet. It should be in the next 6 months. But we're adding SQL support. Many developers have asked us that. Because when they have existing apps, the big table model, it's too much of a pain to just change your data model and just alter your schema in order to make it run on App Engine. And SSL on your domain is another feature that's interesting for companies. Now, when we talk about the cloud in general, I told you a high-level overview of it before. This is kind of the way analysts see it. So at the bottom, you have infrastructure as a service. This is typically when you're renting virtual machines with EC2 from Amazon or S3 for storage. Basically, you take all these capacities that you have in the cloud and you build your own distributed computing solution on top of it. So your own scalable architecture. The advantage of this approach is that it's very close to what you're doing today if you're owning your own data center, except that here you're renting. But the disadvantage of it is that you still have all the architecture to build by yourself to make scalable distributed computing application work well. Now, the level on top of it is platform as a service, and this is what App Engine provide. Salesforce.com has a Force.com platform that's very similar. Windows Azure is in this category as well. So what these guys provide, what we provide in this area is we take care of the architecture for you. We just provide platform services through APIs, and if you abide by the limitations of the platforms and the APIs, we guarantee that you'll scale. So in App Engine, there are a bunch of limitations, but if you follow them, basically you can scale to how many millions of users you want and vast data sizes as well. On top of that, there's software as a service, and that's what Google Apps is about. So today, this is what our offering looks like. So we have Google Apps and then Apps Marketplace. And now with App Engine for Business, we have your apps in there. Under that, we have App Engine. And then, for the first time this year, we started to get into the infrastructure as a service market with three offerings: Google Storage, Machine Learning API, and BigQuery. And I'll show you a little bit what that looks like. So that's the domain console. So I told you about the domain console. Google Apps integration, I told you about that. Secure Data Connector is a technology that allows you to securely drill a hole through your firewall to let your cloud application have secure access to data within your firewall. So typically, like accessing Oracle or SAP data inside of your domain. The pricing is different. So for enterprises, it's $8 per active user per month, and it's capped at 1,000. So if you have an app that's used by 2 people, it will be like $16 per month. But if it's used by more than 125 users, like let's say you're a big corporation with 20,000 users, the app would just be $1,000 per month. It's restricted to domain users as well, and development is free. SLA, we have a 3.9 SLA, and then now you can finally pay for support, and you'll have dedicated support instead of having to post in the developer forum. We have a qualification program going on. It's not finalized yet, but it's coming. So if you are an App Engine developer, just watch that space. We will announce it on the blog. So I talked about the fact that it's evolving, and we're constantly adding new services in there. And on the roadmap, there's lots of fascinating stuff like you can have your own background servers or dedicated instances. There's a channel API that was announced at I/O as well, and it allows you to build Comet type of apps. So basically, with all these services, you should take a look at the Google I/O presentation. There have been at least 5 or 6 about App Engine features that are coming up, and there are videos in there plus all the decks of the presentations. Now, very quickly, I want to talk to you about the few infrastructure as a service products that we released recently. All these are so App Engine for Business and all these are all in Trusted Tester right now. So if you're interested to have access, just shoot me an email. My mail is chanezon@google.com. Google Storage, basically it's very much very similar to the S3 service by Amazon. It's using the same API. So the tools that work with S3, like S3 Fox or the Boto library, are all working with Google Storage. It lets you store data into buckets, and then you store objects in there, and you have APIs to set access control on these, and recently we added group access control to that. The main point that's important about Google Storage is that it's the entry point to have access to higher level platform services from Google, the two of which today are prediction and BigQuery APIs. Another advantage of Google Storage is that Google is a very infrastructure-oriented company, and so storage just benefits from the magic infrastructure we have with lots of data centers in many places. and so your objects are distributed in many places. And I've seen some blog posts where people were measuring latency from various parts of the world to Google storage data, and the latency was really good. All right, so there are command line tools for that. The API is a REST API, which means over HTTP using HTTP verbs. There are a bunch of Google properties using it already, and a bunch of companies as well, like Memeo or Snapabug, Simplicity, and Social Work. They're using all our API products. Technical overview, I'll go quickly on this one because I'm running a little bit late. But basically it's a REST API. REST means representational state transfer. It's an architecture style defined by Rolf Fielding in his PhD dissertation. If you have lots of sleepless nights in the winter, I don't know if it's very cold here, but I highly advise you to read his PhD thesis. It's a very interesting document, but you need lots of time on your hand. Essentially, the idea of REST is that he codifies the architecture of HTTP. He's the guy who did the HTTP 1.1 spec. And he codifies it as a style of architecture for building applications. And at Google, we're using REST for most of our APIs through the GData API, which are based on Atom Publishing Protocol, which is kind of standardizing the payload envelope for REST APIs. So Google Storage is a REST API as well. And this is what a request looks like, the signature. There are ACL, so you can specify who has access to what. Yeah, it's very good consistency. The tools you can use, there are tools in many languages because there are lots of tools for Amazon and usually they work with Google Storage. You just need to change the URL endpoint of the service from Amazon to Google. And I'm just going to show you what it looks like. So Google Storage comes with a user interface. I think it's in there. Yeah, so the UI looks like this. These are my buckets. So buckets is buckets are a single namespace through all users of Google Storage. So when you define one, you need to define one like prefixed by something that's very personal to you, else it will be taken already. And so under a bucket, you have a bunch of files. And I'm just going to create a new bucket. So I'm going to call it Chanezon Singapore. All right. So I have my new bucket. Once I've done that, I can go to a command line file, and here yeah. So here I have a bunch of drawings from my daughter. She's doing I mean, those of you who saw me presenting in the years before, I usually use my daughter's drawing as examples, because she draws lots of comic books and it's pretty fun. Here I can do, so I have a bunch of JPEG files. I'm just going to use the gsutil command line. So gsutil is just a thin wrapper on top of the Boto Python API, a Python library, which is, was designed for S3 and has been retrofitted to use Google Storage as well. So I'm going to do gsutil cp start.jpg to GS. And then the URL is the, I give the name of my bucket. So it's going to be Chanezon Singapore. And then he started to copy the files in my Google Storage account. And once they are copied, they are immediately available to users or applications. Oh no, that's Sydney, I want Singapore. Yeah. So I should see them, you see they start to appear in there. I can, by default they're private. Using GSUtil I could change the access control, give access to only a Google group of users, or I can share them publicly and I have a link that I can share with people. And, oh, wait a minute. Oh yeah, I double clicked. So I share it publicly and then I click on the link and then everybody can have access to that. So that's Google Storage for you in just a few minutes. Now, where it becomes really interesting is, so Google Storage, you pay for it, the pricing is comparable to Amazon. There's no SLA right now, it's a trusted tester, the data is limited to 100 gigabyte during the preview period. If you find people who are interested in that, I think right now Google Storage is kind of limited to the US, so it's a little bit difficult to sign up people for it. Now, where it becomes really interesting is services that you can leverage on top of that. And here I'm talking about really, like Google Storage is very similar to Amazon S3, except maybe the perf are a little bit better. But this stuff, it doesn't exist today. There is no comparable services. So these two services are called BigQuery and Prediction API, and these are pieces of infrastructure that we developed internally at Google for serving ads. For example, the Prediction API is used in AdWords and AdSense. It's a bunch of machine learning algorithms that we just packaged all that to give it access to developers, because typically machine learning is difficult to apply. These are complicated algorithms. Another aspect, BigQuery, is our analytics engine that we're using inside Google for ads. And the problem it's trying to solve is how do you do structured interactive queries for like trillions of rows of data, which are, for example, the click stream on ads, where you want to analyze that for a full year, and you want maybe the top or do some statistical analysis on that. So how do you do that in an interactive way? So we developed these services internally, and now we're exposing them to developers. So, all right, the way it works is the same for both APIs. You upload your data within a bucket in Google Storage, and then you either like import the data as a table for BigQuery, or you train a model on that data for prediction, and then you can either run queries or do predictions. So this is BigQuery. Okay, I'll just show you an example for both. But basically it's scalable to billions of rows, and it's very fast response time. The way you define your data, and then after you have defined your table and your data, and you have uploaded it, you can do a SQL on them, or a subset of SQL. And then the API for that is just a REST API where you specify your query, and what you get back is JSON. And that makes it super easy to integrate it with Google Spreadsheet, for example. It's using standard Google technology. And there's a command line for it. It's called the BigQuery shell. And because it returns JSON, it's easy to integrate it in spreadsheets. So here, what they did is that they have one data set that you can use for testing, where they have all the revision history of all pages in Wikipedia. They uploaded that in Google Storage, defined a table for it, and then here in this query, they just have a query that's indexed by what you have in this cell. So when you type Google in there, it's going to look up, like do a select in all these data set to look all the pages that have Google in the title and look at their number of revisions. So it's computing that really fast, and it returns in JSON format, so you can integrate that in spreadsheet and have a graphic in a minute. Prediction API, same thing. The example they give is, so in Prediction API, what you input, BigQuery and Prediction, what you input is a CSV file, comma-separated value. So in BigQuery, it's a CSV file with rows of data, and the columns are what you use for your SQL request. In BigQuery, the first column is what you want to predict, and then the rest are features, and features can be either text or numeric. And this is an example of a file where we have thousands of sentences in various languages, and the input file is language, colon, sentence. You train BigQuery on that, and after that, you can do a request. When the training is over, you can do a request to the prediction API to ask, here is a sentence, what's the value of the first column, which is the language? And it works pretty well for this very simple example. So the API is also a REST API, and so that's what the data looks like. So to train a model, you ask the service to train on a specific bucket and file within Google Storage that you have uploaded, and it will give you back model info, which is the estimated accuracy of the training. And once the training is finished, you can just send an instance of data, and then it will return you a prediction. So it works pretty well with a simple example. Okay, what I wanted to show you is a real example that I built. And I have to admit it's not completely fully baked. I just finished it before doing this trip in Southeast Asia. But it's kind of working, but the quality of the training is horrible. So the idea is this. I've been using Delicious, which is a service that allows me to tag links, to apply a series of tags to links for 6 years, and I have 6,000 links in there, to which I applied, I think, 14,000 tags. So I use the Delicious API to pull all this data. And Prediction API should be pretty good for that. Basically, I have all this categorization, and this categorization is very personal of all these links. So if you look at my Delicious data, I use tags like, I don't know, let me show you what it looks like. Yeah, so you see I have App Engine, I have Closure, but I also have some tags that are very personal to me. For example, yeah, so for example, I have some tags called Geek Friends, which are like techies who are my friends, and I tag that with that. If you would ask a general purpose recommendation engine to recommend me some tags for links, these tags wouldn't correspond to my own taste. So what I wanted to see is if I could get Prediction Engine or the Prediction API to just train on the tags I am using personally to tag stuff, and then when I'm browsing to a page, just show me the tags I would have used for it. So what I did is that I used the Delicious API, pulled all the links, then I wrote a little script that just screen scraped all the links, cleaned up the text, and so I have this huge file with, which is tag, colon, URL, colon, the whole text of the page. And I had to like cut the file short because the volume was too much. Prediction API is limited to 100 meg right now. And so once I have that file, I uploaded it to training, or I uploaded it to, actually, let me show you the bucket. I think it's, yeah, it's here. I uploaded it into my Shanazon bucket here, and it's called cleantags.c. No, cleantags was too big, and I hadn't read the doc. It's called small tags. Yeah, it's 92 megs. So smalltags.csv is the CSV file. Then I asked the Prediction API to train on it. And then I asked what's the quality of the training, and this is where I need to do more work on that stuff. Oh no, so I don't want to show you that yet. I just want to show you how you can So there's a little command line that they give you that allows you to check. Yeah, it's called check training. Yeah. Mm-hmm. Oh, no. Okay, so I'm going to check the training on my Chanezon / small tags.csv file. So that's doing a REST request to the API with my credentials, and then it's going to give me a JSON data structure where he tells me, okay, the model has trained on your data and the accuracy is like 6%, which is like ridiculous low. So what that means is that what I'm going to show you doesn't work well yet. Before I went to Manila 3 days ago, I tried a different cleanup algorithm for the text, and I just finished it on stage, and the training accuracy was 1%. It was even worse. So I'm just going to show you how that works. So here I pass to it URL. So that's a URL, that's a new URL that's not part of the file. Actually, let's take something from today. If we go to TechMimi, we just take, like there's a new Apple TV, so I hope it will, so I just take this URL, and I'm just going to, oops. Yeah. So I pass it the URL, and what the script does is that it fetches the content, cleans it up, passes it to the production API, and tells me, okay, what's the tag that you will have used for that? Apple! That works! So sometimes I get really crazy results with 6% accuracy. The last thing I wanted to show you is, for this example, what I did is that I also define, because I have this file with tags and URLs, I also define, I wrote a quick JSON file to define what the table was like with the 3 columns. And that allowed me then to use the BigQuery API on top of it, so I can do queries on it. And I think I have, I think it's called Qt Shell. Oh. It's called BQ Shell, so BigQuery Shell, and I think I have a bunch of can queries. So for example, I want to select all the tags, or maybe I want to count the distinct tags that I have in my table. So I just paste that. Here we go. Yeah, so I have just 1,300 tags. But then I can do some more interesting stuff, like select the top 100 in there, based on the count that there are in there. And that kind of query, so on tags here, it's like a very small data set, but you could do that with like a billion row data set, and the query result would still be pretty fast. That kind of sums it up for all the Google Cloud technology, and I really run late, so I need to stop. Are there maybe, do I have time for question or no?
2 questions.
Okay, 2 questions. Any taker? Yes?
How much is this big table thing if I want to store like gigabyte size data?
So how much is Google storage for storing like a big... BigQuery? Yeah. So today, this is in Trusted Tester, so you need to be whitelisted to have an account. And during the Trusted Tester, all these services that are supposed to have like gigabytes or terabytes of storage are limited to small amounts. So storage, I think, is limited to 100 gigabytes. BigQuery and prediction are limited to 100 megabytes. Like even for my very simple example, I had to cut it down. But that's only for the Trusted Tester period. When this goes to production, you'll be able to use that for like much bigger volume. Any other question? Yes?
You just mentioned that we would be able to use it for much bigger volume. How do we get that volume up there?
How do you get this volume up there?
Yeah.
So Google Storage, how do you get your data into Google Storage? Two options. The first one is to use the REST API, but then I guess if your volume is really big, it's kind of slow. Now, for people who will have huge volume, you can send us some hard drives and we'll just put them in there. It's called, I think in the early internet, it was called the sneakernet. So you just take your hard drive and you bring it with carrier pigeon and we'll take care of it.
Are we going to be paying for the flight tickets?
FedEx? That was two questions. I'll be around if you want to discuss on some of these upgrades. All right, now Christine, for the next, I think we're going to have lots of demos.
Yes,